Good day, grade 11 students. It's me again, Sir Chris, your general mathematics teacher. How are you today? I hope you are all fine and having fun of learning math. Are you excited to learn another cool topic about general mathematics? If yes, like this video, subscribe, and click that notification bell for more exciting math videos. Last time, we learned that functions can be performed by the operations addition, subtraction, multiplication, and division of functions. You have also learned how to perform the composition of functions. And now, to begin with our new discussion, you must be acquainted first with the skills or competencies that you need to obtain in this video lesson. At the end of this video, you are expected to Number 1. Represent real-life situations using rational functions. Number 2. Distinguish rational function, rational equation, and rational inequality. And number 3. Solve rational equations. Have you heard the word rational before? Back in grade 8, you have learned that rational algebraic expression, which is an expression of the form P of x over Q of x, where P of x and Q of x are both polynomials. Just like rational algebraic expression, rational functions also have polynomials in its numerator and denominator. In general, a rational function is defined as the function of the form f of x equals P of x over Q of x, where P of x and Q of x are polynomial functions and Q of x is not a zero polynomial. There are a lot of situations in real life that are modeled by rational functions. And to help you understand the concept about rational function, let's consider this situation and do the accompanying activity. Example situation. The Barangay Pag-asa received a budget of 100,000 pesos to provide medical checkups for the children in the barangay. The amount is to be allotted equally among the children in the barangay. Now, let's fill up the table with the different allotment amounts for different values for the number of children. We have a column for the number of children represented by the variable x, and another column for the allotted amount, which depends on the number of children represented by f of x. The question is, what will be the allotted amount if there are 10 children and the budget is to be allotted equally to the number of children? Yes, you are right. If the budget is 100,000 pesos, we can simply divide it by the number of children given. So 100,000 divided by 10 is equal to 10,000 pesos for each child. If there are 20 children, there will be 5,000 pesos given to each child, because 100,000 divided by 20 is 5,000. What if there are 50 children? That's correct. 100,000 divided by 50 is 2,000 pesos. And if there are 100 children in the barangay, the amount allotted to each child is 1,000 pesos, because 100,000 divided by 100 is 1,000 pesos. Based on your answers, we can now write a function representing the relationship of the allotted amount per children as f of x with the total number of children represented by the variable x. How did you come up with the amount allotted for the different values for the number of children? Again, we simply divide the budget 100,000 pesos by the number of children. Therefore, we can express it into a function f of x is equal to 100,000 divided by x. The function we stated is general to all other values of x. Now that you are already familiar with rational function, let's come now to our next discussion. Now let's study and distinguish rational functions, rational equations, and rational inequalities based on their definition. Earlier, we defined rational function as a function in the form f of x equals p of x over q of x, where p of x and q of x are polynomials and q of x is not equal to 0. Another way to identify a rational function if it involves rational expression, two variables, the f of x and the x, and it also have an equal sign. Next, we define rational equation as an equation involving rational expressions. It involves one or more rational expression, only one variable, and an equal sign. And lastly, a rational inequality is an inequality involving rational expression. It involves rational expression, only one variable x, and have one of the inequality symbols. These inequality symbols are less than, greater than, less than or equal to, and greater than or equal to. And to help you further distinguish the difference among the rational function, rational equation, and rational inequality, let's observe the following examples. Example 1. We have f of x equals x squared minus 25 over x. Is it a rational function, rational equation, or rational inequality? That's correct. This is a rational function because it is a function in the form f of x equals p of x over q of x. How about example number 2? We have 5x plus 2 over 3 equals 15. Is it a rational function, rational equation, or rational inequality? You're right. This is a rational equation. As you can see, there's a rational expression and an equal sign. How about this one? We have x minus 1 over x minus 3 is greater than x minus 4 over x minus 5. That's right, it is a rational inequality because it involves rational expressions and an inequality symbol greater than. On our last example, we have cube root of x equals x minus 5. Is it a rational function, rational equation, or rational inequality? None of this, because this is an equation but it involves radicals. So this is not a rational equation. A rational function expresses a relationship between two variables such as x and y and can be represented by a table of values or a graph. While a rational equation or inequality can be solved for all x values that satisfy the equation or the inequality. To solve a rational equation in one variable x means to find all the values of x for which the equation is true. There are ways to solve rational equations. Step 1. Find the least common denominator or what we call the LCD. Step 2. Multiply each side of the equation by the LCD and simplify. Number 3. Solve the resulting equation. And step 4. Check the solution with the original equation. For you to fully understand how to solve rational equations, let's have this first example. Example number 1, solve the rational equation 1 over 7x equals negative 1/3. To solve for x, let's start finding the LCD or the least common denominator. The denominators here are 7 and 3. 7 has a prime factor of 7 and 3 has a prime factor of 3. Thus, the LCD is 7 times 3, which is equal to 21. Next, we multiply the LCD to both sides of the equation. We have 1 over 7x times 21 equals negative 1/3 times 21. 21 times 1 is 21, divided by 7 is 3, times x is 3x. On the right side, 21 times negative 1 is negative 21, divided by 3 is negative 7. Now, we have the simplified equation 3x equals negative 7. To solve for x, we need to divide both sides by 3. 3x divided by 3 is x, and negative 7 divided by 3 is negative 7 over 3. So, we have now the solution of x equals negative 7 over 3. To check if the solution is correct, you can substitute the value of x, which is negative 7 over 3, to the original equation. 1 over 7x equals negative 1 over 3. On the left side, you have 1 over 7 times negative 7 over 3. You can divide negative 7 by 7, which leads us to negative 1. And 1 times negative 1 is negative 1. And 3 times 1 is 3. If it satisfies the given equation, then x equals negative 7 over 3 is the solution of this rational equation. Easy, right? Just follow those steps and you are good to go. Let's have another example. Solve the rational equation x minus 5 over x plus 7 equals 5 over 17. Following the same procedure, we have the denominator x plus 7 and 17. X plus 7 is a polynomial with no factors other than itself x plus 7. And 17 has prime factor 17. Finding their least common multiple, we have the LCD 17 times x plus 7. Next, we need to multiply the LCD 17 times x plus 7 to both sides of the equation. We have 17 times x plus 7 times the quantity x minus 5 over x plus 7, which is equal to 17 times x plus 7 times 5 over 17. On the left side, we can divide x plus 7 by x plus 7, which leaves 17 times x minus 5. On the right side, we can divide 17 by 17, which leaves us x plus 7 times 5. Applying the distributive property, 17 times x is 17x, and 17 times negative 5 is negative 85. Then, 5 times x is 5x, and 5 times positive 7 is positive 35. We will subtract 5x and add 85 to both sides of the equation. We now have 17x minus 5x equals 35 plus 85. 17x minus 5x is 12x, and 35 plus 85 is 120. Finally, dividing both sides by 12, 12x divided by 12 is x, and 120 divided by 12 is 10. Therefore, x is equal to 10. And to check, substitute x equals 10 to the original equation. X minus 5 over x plus 7 equals 5 over 17. We have 10 minus 5 over 10 plus 7 equals 5 over 17. 10 minus 5 is 5, and 10 plus 7 is 17. And 5 over 17 is equal to 5 over 17. Therefore, x equals 10 is the solution of the rational equation. Solving rational equation is easy as long as you know the concept of finding the LCD and solving algebraic equations. Now, let's try to solve this next example. Solve for x. 1 over 2x plus 5 over 4 equals 3 over x. Again, let's find first the LCD of 2x, 4, and x. 2x has factors 2 and x. Prime factor of 4 is 2. 4 is not included because 4 is a composite number. Factor of x is just x. Thus, we have the LCD of 2 times 2 times x equals 4x. Next, we need to multiply the LCD for x to both sides. We have 4x times the quantity 1 over 2x plus 5 over 4 equals 4x times 3 over x. 4x times 1 is 4x divided by 2x is 2. 4x times 5 is 20x. Divided by 4 is 5x. Then, 4x times 3 is 12x. Divided by x is 12. Now, you have the simplified equation 2 plus 5x equals 12. Subtracting 2 to both sides of the equation, we have 5x equals 10. Finally, we will divide 5 to both sides. 5x divided by 5 is x, and 10 divided by 5 is 2. Now, we have the solution x equals 2. To check, let's substitute x equals 2 to the original equation. We have 1 over 2 times 2 plus 5 over 4 equals 3 over 2. Simplifying it, we have 1 over 2 times 2, which is 1 over 4, plus 5 over 4 equals 3 over 2. 1 over 4 plus 5 over 4 is 6 over 4. And 6 over 4 can be simplified in lowest term as 3 halves. Therefore, we can say that x equals 2 is the correct solution for the rational equation. To summarize our lesson today, you have learned that rational function can be used in real-life situations. Also, you learned how to distinguish rational function, rational equation, and rational inequality. A rational function is a function in the form f of x equals p of x over q of x, where q of x is not equal to 0. A rational equation is an equation involving rational expression and an equal sign. A rational inequality is an inequality that involves rational expressions and inequality symbols. And lastly, you learned how to solve rational equations by finding the LCD, multiplying the LCD on both sides of the equation, simplifying and solving for x, and checking the result with the original equation. And there you have it. You may think that solving rational equation is difficult, but it's time to end that thinking. Just study and always practice solving other rational equations, and you can easily get the hang of it. Hope you learned a lot about this lesson we have. Happy solving and keep safe everyone. Thanks for watching.